Well, hello everyone. It's a great pleasure to be here with you all. I've been looking forward to coming here and present my work. And I think the most important thing is that I spend my day in the lab surrounded by academics, and we live in in our bubble. And it's very nice to come out of that bubble and talk about our ideas and what we've been doing. And I would love to get feedback. Is what I'm saying, does it make sense? Is it nonsense and we're just living above the clouds or not? So please make this interactive. If you have any questions, just raise your hand, interrupt me. We can, of course, always get the last part of the talk, but I think what is more important is to get these interactions, to get this feedback. And before I start, just to know you a little bit, do you want to tell me if you identify yourself as someone who works in data management broadly, databases, like IoT, data-related type of work? Do you mind raising your hand? Right, good. So there was a few of you. This is great. So I think that's a good composition. And of course, for all the rest, I think this is a great opportunity also to let us know, because a lot of data-related work is really about other fields. So let me know, how does that connect with you as well? So what I'm going to be talking about today is what I view as the new transformation in a changing world in technology. Currently, everything is consolidated into these large-scale data centers, the cloud. But as I'm going to argue, this might be changing. And what led me to start thinking about this is, some of you might be familiar with these technologists, Ray Kurzweil and Kevin Kelly. And although they might have some controversial ideas, something that stuck with me when reading their books is this graph over here, which shows that there is an increasing pace in the amount of calculations per second per $1,000. And we've seen how this increase has led to revolutions in technology. And we are continuing to experience this. Actually, just yesterday, I think a lot of us were amazed by what happened with GPT-4. And really, these advances in technology are going to keep going. And it leads me to think about what is the future of technology and what is holding. And what fascinates me the most is the time when we're going to be surrounded by technology. So when we think about smart cities, smart spaces, interactive, real-time applications being immersed with technology and things like virtual reality and augmented reality, all these things are going to change how we live our life and how we live in our surroundings. And the way that I'm dealing, or the way that I'm interfacing with these goals and visions, is by knowing that there is a need for a data management infrastructure to realize these visions. And this is what I'm passionate about and what I'm going to be talking to you about today. And the reason why I think that there is a transformation that is happening is that a lot of these technologies that are going to be shaping our future are technologies that require really fast response. So if you look at things like virtual reality, we need a response time, a motion to photon time that is less than 20 milliseconds and sometimes even in the single-digit milliseconds. And when we think about things like latency-sensitive applications in the IoT domain, this also can be in the tens of milliseconds. But when we look at the current infrastructure today, to get to the nearest cloud data center, it might take us tens or hundreds of milliseconds, which makes us unable to support these types of applications that we envision happening in the future. So what is it that we're missing? We're missing a data infrastructure that is going to allow us to do real-time computation and to be closer to users. And the cloud centralization in general has been wonderful. It allowed a lot of cool things, cool applications that we enjoy today. However, they represent a limit to what we can do next. And when we think about, well, if the cloud is not the answer, what would the answer be? One way for us to think about this question is to reflect on the history of technology. And something that is very interesting when we think about the history of data infrastructure in general is that it goes through these two extremes, these cycles between the extremes of consolidation, when we're trying to put all the compute resources together very close to each other so that we can do more with them, similar to what happened, let's say, in mainframes in the 70s, similar to what happens with the client-server model, and now the cloud that we enjoy. But also, there's been phases of distribution. And that is when consolidation just took it too far, and now we need to get a little bit closer to the user. And that's when we saw kind of like things like peer-to-peer networking in the early 2000s and the success of peer-to-peer networking because we wanted to do things closer to users. And what I argue here is that we are getting into the next phase of computing here, moving from the cloud into the global scale edge, which is the name that I give for this next phase, where we're not going to be confined by data centers, but you can think of it as data centers going beyond those consolidated buildings and actually getting closer to the users. And this is how I imagine global scale, the global scale edge would look like. This is a map of Irvine. And if you think about these applications, an autonomous vehicle, like different IoT devices and applications, instead of having to go all the way to the cloud for every single detail, what could happen is that we'll have all these stars, and each star representing here an edge device or an edge machine that is going to help us in processing the data and processing the applications closer to the users with very low latencies. So with this type of idea, well, what stops us from getting there, and what is the progress that is happening towards this new phase? And when we see a lot of the recent technologies that are around, that are kind of like a lot of the progress that is happening, we see that there is these signs that we're getting closer to this global scale edge. For example, we see that there are multi-data center systems, things like Google Spanner, Yogabyte, and other databases that are now, instead of building them as consolidated databases in one data center, they're actually being built to be distributed all around the world. We see a lot of new data management technologies that are specifically designed for the edge cloud, where things like Firebase, PouchDB, those are designed to be closer to the user and interact with some centralized database. And even technologies for disaggregation. When we think about serverless technology, this disaggregation might serve us to go beyond the data center. In fact, when we have this way of processing in a stateless manner, now we are getting free from the state that might reside on the data center. And what I see is that we are slowly, one step at a time, moving into this new phase of the global scale edge. And what is needed is a way to realize it. So this is going to be my talk today. It's going to be about how are we going to realize this global scale edge. And I'm going to talk about two main areas of work that we've been doing in the lab. And these two areas of work are done in collaboration with our industry collaborators. The first one is our vision of a data infrastructure for the global scale edge. And in it, we work with AnyLog, which is a startup that aims to build this technology of a data infrastructure on the edge. And we're transferring some of the lab work that we're doing in the university into the system that we're building with AnyLog. And later in the talk, I'm going to talk about some of the challenges that we're facing when we're designing systems for the global scale edge, which is work that is supported by Meta. And I'm going to talk about some of the things that we're doing there. So before we kind of get into the depth of the technologies that we're trying to work on, one question that might come into mind, kind of like, well, this makes sense if we put more resources closer to the users. Well, we're going to do things faster. We're going to kind of like stop relying on sending everything to a centralized location, which will also reduce costs. But why are we not seeing all these edge resources around us, right? So yeah, take a minute, think about it. Obviously, there is a lot of advantages to having all these edge resources that are going to perform computation on our behalf. But why are they not there? So yeah, perfect. Like, let's spend like 10 seconds thinking about it. If you want to volunteer to share what you think is the reason, feel free to do so while we all think about it. That's good, right? So security is an issue. If I have all these devices around me, well, maybe that is going to be a security risk. But at the same time, that didn't stop the water company and the electricity companies from actually having resources closer to to dwellings and homes. So of course, it's a big concern that actually we're going to talk about. But there might be also something else that might be preventing us from getting to this world. Yes. Wonderful, right? Cost. And in a way, who's going to pay for all of this, right? And this is the missing piece. For us as technologists, as people working on these systems, we tend to think about the technical challenges, right? But when we think about this is more of a business challenge. When Amazon or Microsoft or Google builds a data center, they build it because there is a financial, economic reason and advantage that they get with that investment. However, with this, can we think of an entity that can build or can distribute all these edge devices all around cities, all around the world? No one entity can have all these resources. Yes. Wonderful. That's a very good segue. And I think we're going to get to it actually in this slide, in this missing piece. But that's a very good observation. Yes?
One other thing, you do speed tests on your computer, so it goes to somebody's site. Well, wouldn't it be worthwhile to take some of these sites and make it economically better for them?
Oh, absolutely. And I think this is a very good observation as well, where it's demonstrating the benefit. And through these, let's say, partnerships with telecom companies who might have this infrastructure, and showing that by these partnerships it might work. I think that's a very good observation. And actually, I think we're getting there. But let's take maybe one more. Yeah, go ahead. Oh, that's a very good question. And actually, that's the first piece of work. So that's one of the main things that I think prevents us from having this huge network of machines. How are we going to synchronize between all of them? When everything is consolidated, of course, it's an easy issue, but that's one of the challenges, which is, I call it coordination, which we'll get to in the talk. All right. So all very good observations, and in a way, I'm not going to set it up because you're already there, all of you. Which is the reason why we're not there is that because we need this new model, a new economic model of how we're going to build this new infrastructure. And as some of you alluded to, telecom companies already have an infrastructure that can support this. And actually, a few years ago, they started realizing the economic impact and the economic advantage that they might have alongside data center providers and cloud providers. So we see, for example, that Amazon AWS made a partnership with Verizon. We see Microsoft Azure making a partnership with AT&T because they're seeing that the future is actually going towards that direction. That the cloud and compute that is happening in data centers is slowly going to be pushed closer to these base stations that are closer to users. And of course, this is already happening for decades for certain types of applications like content delivery, for example, think Netflix. But this shows that it's going to happen at a much larger scale, at a wider scope when we think about cloud applications. So by the way, thank you for all the questions. Please keep them coming. I think this is really really good to participate as well. So now when we think about this new model, let's call it the contract edge model, where instead of having one entity that is going to control all the infrastructure, it's going to be a lot of entities that are contracting with each other. So for example, you can see that with this color code, some of the edge nodes might be managed by a cloud provider, some of them might be managed by telecom providers, and some of them might be managed by other entities like universities, like companies, private entities. All of them participating in this network of machines that are closer to the edge. Yes. Go ahead.
What you have up there, you're showing more or less like automobiles or other things. But one of my projects right now where wearables, where people are going to be wearing devices that need to connect, especially if they have a medical emergency.
Yeah.
So you're going to need more of those people. You're talking
Yeah.
about thousands of people in New York on one street.
Yeah, that's a very good. That's a very good point, and kind of like especially for health-related applications, one of the collaboration that we're making, or the project that we're making, are actually with care centers for the elderly, and in those care centers, especially kind of like for guests of these centers who have some medical conditions, every second matters. And actually, it's already happening. There's these wearables, kind of like signals are continuously being propagated and collected from devices, and they need to be, and we need to react to them instantaneously. So, kind of like to your point, this is a very good point that even this granularity, even this scale, we need more. Like even inside buildings, inside machines, we can think that this is happening more and more. Yeah. Go ahead.
This kind of reminds me of
Helium, I'm not sure. Yeah.
where people can go set up their own like LoRa-based almost like routers that are hooked up, and it just allows third-party companies to go and basically rent data off the customer.
Interesting. Yeah.
Set up hotspots, any customer can pay like $300 for it, but the
Yeah.
currency has basically
Yeah.
it does remind me of this.
Yeah. Actually, I think about of I think of like a cryptocurrency by the name of Helium. Kind of like did sound familiar to me. I know that there's actually some other players in the space of cryptocurrencies and blockchain in general who are kind of like still adopting and pushing this. And but yeah, kind of like I think this is really going to be some of the enablers of this technology, right? Kind of like how are we going to incentivize users from providing their services and machines and resources? Yeah, that's a good point. So kind of like now with this, this is kind of like our first piece of work, which is this collaboration we're doing with the startup AnyLog, where we're trying to build this infrastructure that is going to be distributed, that is going to allow us to manage data at the scale of the global scale edge. And one way to think about AnyLog is that we start from the physical infrastructure of the contract edge model, and now we start thinking about the problem, some of what you mentioned in terms of like how are we going to coordinate data, how are we going to discover where data is, how are we going to publish data, all these questions, like how are we going to do them? We don't have a single database or a single program that is going to manage everything that is going to be that is going to know everything that is going on. So we need a way to discover data. We need a way to coordinate data and coordinate between different edges. And AnyLog is providing this. So you can think of it as that data, for example, are being published from this autonomous vehicle, and it discovers what are the edge nodes that are around it to send it to the closest edge node. And once this data is being sent and distributed, we use a public or private blockchain. And here I use blockchain kind of like in a very broad term. You can think of it as any type of metadata store. It could be a distributed system. It could be kind of like a consortium of different companies or different government organizations who are maintaining that data on the behalf of all these contract edges. And it's going to be the only type of data centralization, but it's not for the data. It's only for the control and meta information. So the coordination between these edge devices, discovering where should I send data, where should I query data, that's going to be discovered through that location. And now, if I have something like a query that I have at the top right, which is, well, I want to know all the cars that entered the campus of UCI this morning, I'm going to know that I'll need to direct my query to those 3 edge nodes who have that relevant data. And by having access to that relevant data, I can get access to it, get the answer to my query, without having to propagate my data to a centralized location, without having to process the query across all the different devices that are around the city. Sure. That's a very good question. And actually, that's one of the first, unfortunately, I'm not going to cover that part of the talk, But in our first white paper that we wrote about this system, AnyLog, the issue of data ownership is one of the main issues that we touched on. And in this case, the way that we argued about it is that we are trying to incentivize the publishers to publish their data. And AnyLog is going to build the mechanism so that if someone queries this data, they're going to be paying either directly or indirectly the publisher of that data. And actually, a lot of the cryptocurrency and blockchain projects, such as the one I mentioned before, were built on that premise, that they're trying to manage this data ownership. They're trying to incentivize people to share their data. And the way to incentivize this sharing is that you're going to be paid if someone uses that data. Yeah. But that's a very good point. Yeah, that's a very good point too. So there are some relations to kind of like decentralization and Web3. And kind of like that's the reason kind of like why when we think about kind of like the entity that is managing the metadata or the control data, I mentioned the word blockchain because I want to emphasize decentralization. However, it's not a requirement or it's not kind of like a core part of the solution here. Because if you think, let's say, about a city and maybe kind of like those entities try to coordinate with each other, this centralization or this entity that could be centralized could also be a consortium blockchain or system that is managed by the telecom companies, right? So definitely we are trying to build on the advances that are happening in decentralization, but we're not relying on it. Yeah, that's a good point. Yes.
Since consumers know which edge nodes they're querying from, doesn't that expose those edge nodes to potential cyber attacks?
Yeah, absolutely. So definitely, that's one of the risks that we have to deal with. For us, from our side, we did not deal with that specific challenge, but of course, kind of like these intrusion detection, kind of like hiding data and data sources. This is like there's literature on that we can utilize here, and that's kind of like a lot of challenges that actually kind of like I think is wonderful that all these ideas and challenges that you bring up are really kind of like part of this, and we're going to talk about a subset of them in the rest of the talk. Yeah, but yes.
I'm concerned that this might be setting up perverse incentives to collect data from everyone and everywhere and morph into kind of a surveillance state that is being run by people who have money. For instance, I'm not picking on this specifically.
Sure.
Cars that entered UCI this morning is really not a value that probably should be published or collected. It's an invasion of privacy somewhat.
True.
So incentivizing people to collect that information, make those kinds of queries possible, is at the very least an ethical challenge.
Yeah. I think that's a very good point, and I completely agree with you. And that's where the challenges in terms of access control, encryption, might help out in kind of like in those challenges. But at the same time, kind of like I agree that in a lot of these cases, of course, we deal with it in a lot of applications. And like to give you an example, at UCI, we've been working on a system that is going to kind of like within the computer science building, there is an edge IoT system that is going to collect the occupancy of how many people are in each room. And of course, kind of like initially, kind of like with like anyone would think that this could be like used in different ways. Well, why are we doing this? And then the pandemic happened, right? I think kind of like this line of kind of like what data should I collect, what data should I not collect, kind of like becomes blurred because like now we want to know about the occupancy of different buildings, of different rooms, and it started kind of like being used at the university level. But kind of like to answer the question generally, I think kind of like certainly different usage of this could be unethical, and collection of data could be unethical. But in a way, this is the case of any data technology, right? It's about who is going to implement it. It's about who's going to realize it, to control what data is going to be shared, how it's going to be accessed. Yeah.
this data has value from UCI's perspective, and UCI probably has a right to collect this data for security reasons or for their logistics planning and so on.
Yeah.
But I think this point is data is generated by the end users, in this case automobiles.
Yeah.
And data is generated by end users. Okay. The data is generated by end users. Now UCI has important or value in the data, but if these other players, and in this case market players you are using, if they start using the data and with their different motivation, that's a real concern. I think that's
absolutely.
the valid point.
Oh yeah, absolutely. I think I couldn't agree more. The issues of the ethics of what data is being collected, how it's going to be used, is certainly an important thing. But I think it's certainly mechanisms to control this, similar to how it's being done currently in data systems, can be applied here as well. Yes. Sure.
Point of overload. What happens when you hit that brick wall?
That's so. Yeah, sure. So certainly, so in terms of overload of these edge devices, actually that's also part of the challenges that we address, is how to distribute the load. This issue of load balancing between these different edge devices is necessary. Of course, you can, like in any type of data system, you can reach a point where it just can't be supported, whether it's distributed or at a different location. But yeah, certainly this load balancing could be an answer to that. Yeah. So yeah, wonderful insights. We're going to touch upon some of these, but of course I'm going to stick around also a little bit after the talk, so can talk more and get some more of your insights as well. And the setup of these devices, of these edge devices with AnyLog, they manage the different tasks that you could imagine in terms of configuration, policies which touch upon some of the data sharing issues. If I'm collecting some data, what are the policies that are involved? For example, is there some data protection regulations like CCPA, where it prevents me from, let's say, collecting certain parts of data, or maybe I need to anonymize certain parts of data. And then in terms of functionalities, I need to deal with how I'm going to ingest data, store data, share data. So all these each one of these bullet points, it's its own talk, right? But in a way, we're going to touch upon some of these. And before we get into some more of the technical implementations or designs of what we're doing, I just want to give you a taste of how this would look like from the perspective of someone using the system. So this is a dashboard that we utilized in one of the users of the AnyLog system. You can think of it as a smart city application. We're collecting data, and we have a dashboard showing a unified view of all this data that is being collected. Here is a map of of the current deployment of a few or a number of AnyLog machines around the world, and some of them is generating data, and we can query that data by writing a query in one of those machines as a client, and then it would discover which are the AnyLog nodes that we need to direct the query to. So as an example, this dashboard here, we go to, I'm going to show the demo over here, and what I'm going to run over here is a query that is going to ask, I want to get the information or videos about cars based on the speed of these cars. So imagine if you're trying to collect or write tickets based on speed. This is definitely unethical, speaking as someone who got some of these tickets before. But let's just go with it. So we sent this query, which is asking, well, give me information about cars with their speeds. And see, I'm ordering in the query, I'm ordering all the cars that are recorded in the database, the data that I collected based on their speed. So for example, if I go a little bit down, now I see other cars. And something that I want you to notice is that the second column here represents the source of that data. So you'll see that some of this data comes from the AnyLog node that is in Atlanta. Some of it comes from other cities. And if I go ahead and select some of this data over here, all right, and what we can do is that kind of like now we've pulled that data. So kind of like I discovered the data, I viewed the data, and now kind of like I can look into a specific one. And if I press watch over here, for example, I'm going to get the footage that we got for that specific data item. Right, so kind of like what I want to emphasize here is that in this example, imagine kind of like if data is being collected at these different locations, now when I send a query or when I write a query, I only discover it on those edge locations. Of course, this is kind of like a simplified demo, but think of this type of infrastructure, but with edge devices that are covering a city or covering kind of like a more densely populated place. Yes. So the query that I just did. So the video. Sorry, say that again.
Demo data or stuff that's actually deployed and.
Oh, that's good. So the video is something that is recorded that we just sent over and over again. But the querying, the data that we got from Atlanta, from the Middle East, all this happened while I'm showing you now. So kind of like, this is another issue. Kind of like, although that the data is distributed all around the world and it's being collected at different locations, it took us kind of like a very short amount of time to even pull that data and query it. Yeah, actually, thank you for bringing this point up. I should have emphasized that. Yes. Yes. Yeah. Oh, absolutely. Yeah. So resilience in terms of redundancy, this is something that we also implement. So we do it in the typical way that is being done, like even in data centers, which is every piece of data is replicated 3 ways. Of course, this is configurable. Some data is important and you want to replicate it. Some data, actually, it turns out in IoT applications, you can live with losing it, right? As long as you can access the other data. So it's a trade-off that we can play with. Yeah. All right, very good questions. Yes. Yeah, that's a very good point as well. And as you allude to, if we don't have this type of information, this means that we're going to go and ask all the nodes, all the AnyLog nodes, and this is not going to work, right? So we have this, and this is that part that we mentioned, which is the public-private blockchain. That part controls and stores the discovery data, the metadata, and all the AnyLog nodes have that minimal data that allows them to know that, well, this data, for example, data about Atlanta cars are going to be in that AnyLog node. This data about UCI, let's say cars are going to be in that node, and so on. Yep. Right. Yes, go ahead. So sorry, can you repeat that? I think you just like your voice a little bit farther away. Yeah. Oh, good. Yeah. Perfect. Wonderful. I must say something. I think so far you're the best audience that I had, like for a very long time. Because I think of like you're predicting what I'm going to say next, which is this slide over here that mentions that there are research challenges that we need to deal with because the current data management infrastructure, the current technologies, of course, are going to be the core in which we're going to be building on. However, when we think about this amount of scale, when we think about this amount of resources, and also in an unpredictable environment such as the edge, it brings about a lot of challenges that are not being dealt with in existing technologies. But of course, some of these challenges and examples of them are here. So kind of like the first one, some of you kind of like mentioned it before, is how do I do kind of like this distributed processing? How do I coordinate if I have data that is in different AnyLog nodes? Some of it is replicated, some of it is partitioned. Well, I'm issuing a query, I'm expecting a consistent answer. But so how do I deal with this? When I have 3 machines or 4 machines in a data center, that is not really kind of like that big of a problem with existing technology. But when we have hundreds of machines on the edge, that becomes more challenging. Yes.
What you're explaining is in a perfect world. Our economies, our worlds, politics, are going to have a pretty big influence on how this goes together. What is the security of this data?
Yeah.
Like you said, who owns that data?
Yeah.
And I mean, that's something.
Oh, absolutely. Oh, absolutely. So, and kind of like part of the challenges that what we need to focus on here is the issues of trust and privacy. So, as you see, kind of like the majority of the challenges that we're going to encounter are dealing with similar issues, because as you're getting closer to the user, it brings about like very interesting challenges. And sometimes it's not because they're fundamental challenges to the edge, but it's because it's a different way of thinking. If let's say kind of like I'm a company, without naming names, kind of like I'm collecting data from my users and I'm using them in unwanted ways, that's still a challenge, even though that everything is consolidated. But in a way, we got used to it. Now regulations are getting used to it. But if we distribute everything to the edge, this is a complete of like new beast that we need to be dealing with, that we need to think about. Regulators need to be thinking about it as well. So these are very significant challenges, to think about it. Yeah.
So I was going to bring up that there's public-private blockchain, so there could be many of those. The U.S. says, okay, we allow these blockchains to exist, and so all the compute nodes or the edge nodes, fog, talks, okay, we'll publish this type of data that's been set up on our system, publish to this one, and then, we're also allowed to talk to UCI's list of, they want to know about the cars, send the metadata there, and so it's kind of, the edge needs to know the list of systems it's allowed to talk to. So government decree could say, no, these can't talk outside of our country, and then go for legal and technical restrictions to say, okay, you can only talk to the list or the data for meta inside our area.
Absolutely. Yeah, I think that's a very good. That's a very good point, and kind of like touching upon these different ways of restricting access to the data, whether it's as you mentioned, kind of like in terms of regulation, in terms of restricting data movement, which is also the nature of a lot of data protection regulations, such as GDPR and CCPA. But additionally, technologies are kind of like now being developed in terms of like how do I keep my data private by using encryption, by using kind of like these cryptographic methods that will allow me to release my data to a specific population that have the permission to do so, even though that the data itself, the bytes, might be out there, but anyone who can actually make sense of them are the ones who have the keys to them. Yes.
Do you see a future where, because I know you mentioned things like companies or like governments may be using this type of thing, but do you see like the average individual potentially buying into an idea like this to help stake or grow out this type of thing? And if that's the case, then wouldn't you, that might solve your decentralized contract concern regarding that you can pay people for the amount of data that's used, but more so you can even scale the quality of their setup and therefore penalize how poorly it's set up, so you can actually make sure there's actual like consistency in keeping a high refresh rate or low refresh rate in that sense.
That's a very good question too. And actually, like we thought about that question a lot. And actually, we consulted even economists, kind of like in the university, to think about that question. Can we rely entirely on individuals to kind of like to really get into that threshold of kind of like having these resources all around the world? And in fact, there's been some attempts to do so in the past. So in the 90s, in the late 90s, in the early 2000s, especially during the interest and hype of peer-to-peer networks, there's a lot of that, kind of like how to incentivize this. unfortunately, from that past experience and from economic factors that I can't claim to understand, this seems to be unlikely. And what seems to be more likely, and actually, we started with how you're envisioning things. Kind of like, I think for someone coming from computer science, kind of like we always like to give power to the people, and like we don't need anyone, we don't need governments or companies or anyone else, right? But what we started to realize is that there needs to be a strong economic force that is going to lay the foundation of this. But then with this, there is going to be a need for individuals to also be participants in this. And actually, when I say individuals, I also kind of like use it kind of like broadly. Individual, like it could be private entities, kind of like smaller companies, kind of like smaller groups. And this is why these types of challenges are important. If I allow access, or if I allow any type of entity to participate in this global network, I need to trust them. I can't trust anyone that is going to join the network because they might act maliciously. So this is part of what we are designing: is how can we design technologies to ensure that what they're doing is conforming to the protocols, conforming to the designs and practices of the system. And of course, a lot of this, some of them are open challenges, and some of them are things that are solved, and we're in the way there. All right, wonderful question. So kind of like moving along, of course, and you did a wonderful job going through a lot of different challenges, and a lot of these challenges are either solved in kind of like in academia, but they need to be practical. Some of them are still open questions, even from the research perspective. And these are some of the things that we are dealing with when we're designing AnyLog and when we're doing our research in the lab. But in today's talk, I'm going to focus into these like two things only, and talk about them briefly and what we do in the lab in terms of how do I ensure that the data is consistent across edge devices, across the edge, and if I'm using a cloud machine, if I can do it in a complementary way, and also the issue of how do I trust an edge node that is participating in the network. Which brings me to the next part, which is this issue of coordination between the edge devices and also between edge devices and the cloud. And something here to emphasize that I mentioned cloud. Of course, I've been singing all this talk about how we don't we need to go beyond the cloud, but I didn't say demolish the cloud. I didn't say that we don't need clouds. Clouds are still important. They still have their place. But what we need to do is we need to go beyond these confined data centers and realize the advantages of the edge, but we're still going to be utilizing these cloud machines as well. So how are we going to coordinate between the edge and cloud machines in a way that is going to be both efficient and trusted? So the first work I'm going to first piece I'm going to talk about is process, which is about this efficient edge cloud coordination. And later, if we have time, we might skip it. We're going to talk about the trust issue as well. But just to give you the scope of what we're doing here, when we think about this edge infrastructure, all these edge devices, if we place them into clusters, whether they are based on the domain and based on the application, there is two types of main interactions that they do. The first one is on your left here, which is edge to edge, which is also something that we've done extensively in our work in the lab and AnyLog. But also there is this other part, which is the edge to the cloud. How are we going to manage this coordination? Today I'm going to talk about this piece on the right, which is how I'm going to manage the interaction between the edge and the cloud. If I have an application, and I want to say that I want to utilize both edge devices and cloud devices to the fullest, what should I do? And what are the limitations of utilizing only edge or only cloud? And we're going to see that utilizing both is going to give us advantages from both worlds. I want to mention that some of this work we were very happy that it was awarded the Next Generation Data Infrastructure Awards from Meta, formerly known as Facebook, in a way indicating that there is this interest in rethinking the data infrastructure of the internet. And we're hoping that this can be a foundation of how we're rethinking data centers, how we're rethinking data management in the data center and beyond. So yeah, the first work that I'm going to mention is Croesus, and it deals with video analytics on the edge. And the reason why we focus on video analytics is a lot of the applications that we envision on the edge, the ones that actually have most of the excitement, but also most of the challenges, is when we deal with video data. And that could be for applications, whether it's about surveillance, whether it's about video conferencing, social media that is video based, and also things like mobile gaming and virtual reality. So there is a lot of things going on that requires video analytics and processing video data. But doing it with relying on the cloud only is problematic because videos are big, right? Kind of like they have a lot of frames per second. Each frame is huge, and if you're sending everything to the cloud, that's going to be that's going to take a lot of performance, a lot of latency, but also it might even cost you because a lot of applications on data centers actually charge you for data that is either coming in or coming out of the data center. So imagine if you have, let's say, a campus like UCI and you have a surveillance application where you have, let's say, 100 or 200 cameras around the campus or around the city, and all these gigabytes of data are just feeding into the data center, and you're paying for each byte of these data. And if you take it one step further, think about each one of us. If we're using video conferencing or if we're using social media with video data, that's a lot of data. So doing things on the edge kind of like also has these advantages to them. But there is also a challenge. If I'm doing this on the edge, well, edge resources are also limited. Right? So some of you mentioned before that, well, what if I'm constrained in terms in the devices or the edge devices that I'm using? And we're trying to think really broadly, right? So we're not only thinking about these edge devices being large base stations and telecom companies, but also we're thinking in terms of like smaller devices. Those could be devices in the classroom, there could be devices in the office, right? It could be even the device itself that we're using for that application, like a VR headset, for example. So an analogy that I want to make for the relationship between the edge and the cloud is based on the story of Croesus, which is, we use the name for our system here. So kind of like the legend of Croesus here is that there was a Greek king named Croesus, and he wanted to invade Persia. And he wanted to know whether he's going to be successful or not. So he went to the Oracle Delphi. Of course, very well known, a lot of interesting stories, but this is my favorite. And what he did is he asked the Oracle Delphi, should I launch a military campaign against the Persians? Expecting to hear a prophecy, right? Like, go ahead, don't go. And here is what the response was. If you were to go to war against the Persians, you will destroy a great empire. But which empire is it? Is it the Greek Empire or is it the Persian Empire? Right? So kind of like, in a way, what I view here is that this ambiguity is what you would get from the edge. You have an edge device, not a lot of resources. They get some hints from the cloud, aka the gods, and they're giving you this answer. So we need to find ways to be able to work with the limitation of the edge, right? That we don't have full answers, that we have limited capabilities, and we need to be able to utilize them to the fullest. And the main insight that we want to go with is that we want to utilize the edge, the oracle, to get fast answers, but we need to realize that they might be incorrect, and that we eventually need to correct these initial processings. So when we think about it, well, we have two options if we think in the traditional term. Either I do things in the cloud only, meaning that I'm going to send everything to the cloud. This is going to give me accurate results, but it's going to be very slow because I need to go all the way to the cloud and back. The other option is to do things on the edge, which is going to be fast, but its problem is that it's going to be inaccurate. And I'm going to have to deal with this. And the goal of our system Croesus is that we want to develop a solution that is going to give us the best of both worlds, both being able to be accurate but also fast. And the main insight that we start with is that we are going to process our request in terms of two phases. So the first phase is going to give us the fast, inaccurate results from the edge. And we're going to use that to the best we can until we finish the second stage, which is getting the corrections from the cloud. And I'm going to show how this can be useful by following these two stages. And to show you how it's useful, I'm going to give an example of the Cupcake Eater 9000. Imagine that this is the IoT application that we're trying to build, which is going to rely on deep neural networks to identify, and that brings us to kind of like to the image that we saw in the beginning. It's going to detect, well, if it sees a cupcake, it's going to pick it up, eat it, right? If not, then it's not going to do anything and try to search for a cupcake. So, for example, if it kind of like in the edge, we use this smaller deep neural network model that we utilize on the edge because it has lower resources. It might see an image, it says that, oh yes, that's a cupcake, yeah, go ahead and eat it. But then in the cloud, it can correct this for us and say that, oh, hold on, don't go ahead and pick it up, right? And of course, this is problematic, right? We need to be able to correct the inaccuracy, but what if Cupcake Eater 9000 actually did the action, right? And we're going to have a very unhappy dog that is going to be running around, and we need to fix that problem. And there is another problem that is more technical, which is even though that I have this kind of like two stages, I'm still sending all the frames to the cloud. And one of the goals of using the edge is that I don't need or I don't want to send everything to the cloud, and I want to do more things on the edge only. So getting from problem one, we should be able to correct the inaccuracies that might happen. And one way to think about it is that in the first stage, you can do the steps that you can correct, right? So you can prepare doing things, but if there is a step that you think is going to be problematic, then you shouldn't do it in stage one. You should wait for stage two. And in this way of thinking, there are two approaches that we can think of. One is more conservative and the other one is optimistic. So for example, in the conservative approach, the edge Cupcake Eater 9000 is going to identify this image as a cupcake. So it's going to locate the cupcake, extends the arms to reach it, but it's not going to do anything more, right? It's going to wait for the second phase, and then once it gets the correction, if this was a cupcake, if this was not a cupcake, then it's just going to leave, realize that it made a mistake. But if it was a cupcake, then it's going to pick it up and finish the processing. This is the conservative approach. This makes sense. You're not getting into problems at all, right? But sometimes we have some real-time concerns, and we actually want to do things as fast as possible. So the optimistic approach, saying that most of the time we're going to get the right thing on the edge, is that you're actually going to locate the cupcake when you detect it, extend the arms of the robot to reach for it, and you're actually going to pick it up, right? So you're actually going to do the full action. And of course, there is a problem here. But in this optimistic approach, you have to also have a mechanism to apologize, right? Which is, in this example here, well, if it was a cupcake, then you already picked it up, you do nothing, you finish your processing, and you did it as fast as you can. You didn't have to rely on the cloud. And if it was not a cupcake, well, that's a problem, right? You picked up a dog, and now you have to have a way to rectify that problem. You have to apologize, maybe dispense some dog treats, and hope that the dog is going to be happy from there on, right? And of course, this idea of apologizing is not really that uncommon. I don't know how many of you have tried purchasing something from an online store or from an online airline, purchasing a ticket, and everything goes perfect, like the purchase is done, but then you get that email a day later saying that, oh, actually the purchase did not happen, right? So this idea of apologizing is actually something that is done in data management in general, especially for those applications that require fast response. And the other problem, so that's dealing with the first problem, that we need to correct mistakes, whether that it's actually by their nature we can correct them, or that they can be corrected because we can apologize or have a similar mechanism. The other problem is that we still need to send all frames to the cloud to be corrected. And one way to avoid this is to try to have an insight. Once I do the processing with the edge, is that processing with high confidence or not? And a lot of neural networks, especially in image detection and video analytics, actually gives you a confidence on what has been identified. So you can use that to decide, should I send the data to the cloud or should I just continue from there? So basically, you can think of it in this way, that your confidence is between 0 and 100%. And if your confidence is low, then kind of like you discard it because it's probably just junk information. It probably didn't detect anything. If the confidence is kind of like somewhere in the middle, well, this means that, well, it's probably something, but we are not too sure. So that's the spot where we need to send it to the cloud to validate it. And if the confidence is high, that's when we keep it and we don't need to send it to the cloud, because we already have high confidence on that result. And what we try to do in our work here is, how do we identify what are the right thresholds for the validate phase, right? So how low should that threshold be, and how high should that threshold be? Yes.
So, right, this is essentially what we are trying to do here. In the first method, we are compromising accuracy for speed, and you are trying to minimize any irreversible action in the process.
Yeah.
And now we are saying, if before taking irreversible action, you want to validate and improve the confidence. But the edge network itself, or the algorithm that's running on the edge network, that itself, is it learning in the process? Or are you giving that information back to that network?
Yeah, that's a very good insight, and that's definitely going to, like, doing this is definitely going to improve this process. So I'm going to show now kind of like how we identify those thresholds, and as you mentioned, as we train this process more and more and utilize the data that we're collecting more and more, as we're going to refine these thresholds to be better. So certainly doing this continuously would be beneficial. Yeah.
It's interesting.
Yes.
The circular model kind of reminds me of like video buffering. Like you're kind of
Yeah.
getting the motion going, but you're giving yourself time to correction in there. So you're kind of starting the process earlier on, moving faster than before, but
yeah. Oh, absolutely. I think that's a very good analogy. And in a way, kind of like the counter example to this, or kind of like in a way to add to this example, the optimistic one is when you're kind of like seeing it right away, right? So kind of like, yeah, it's definitely like you're dealing with it with that kind of trade-off. So kind of like getting to, well, identifying these thresholds, having an optimization formulation of this kind of like would be one way kind of like that we implemented. I don't want to bore you with all this notation, but there's like two main things that are important here. The first one is that when we think about how do I identify these two thresholds, we need really two main constraints. The first one, I want to make sure that the accuracy I'm getting is above a certain threshold. Accuracy is something that I don't want to sacrifice. So I say that I want the accuracy to always be, let's say, above 99%. But then what I'm trying to maximize is or minimize in this case, is the amount of data I'm sending to the cloud. So kind of like in the formulation here, we take the data that we already have, and we try to figure out what are the thresholds that are going to make sure that accuracy is above the threshold, but also is going to minimize the amount of data that I have to send to the cloud. And as mentioned before, as I get more data, as I train more, as I have more data points for this optimization process, I'm going to refine those thresholds even more. That's a very good point. So actually, these are two. Yeah. So in a way, this would be the one that we're fixing, right? So here we're not maximizing or minimizing this. Here we're saying that as long as this is larger than mu, that's okay. So with fixing it, so as an optimization problem, most probably the accuracy is going to be very close to mu, because your other variable that you're trying to maximize is the saving in terms of the communication. Yes.
You're training a model this way. It feels like, at least for the
Yep. Yep. Yeah, that's a very good and valid comment. And actually, it is by design that we want it to be specific. And actually, one of the things that we need to do for these edge models is that to avoid them from being big, we need to specialize. If we're building a model that is generalizable, this would not fit into edge devices. It would consume energy. It would consume power. So a lot of the work, kind of like also from prior work that deal with edge detection or image detection, specialization is an important key. And what is nice about these applications is that you're already collecting data anyways, right? So it's not like there is a problem in getting specialized data for that type of application. You're continuously getting data, and you can train based on that data. Yeah. Right. Wonderful questions. Of course, continue if you have any questions. Just go ahead. Yeah. So that's a good question too. Of course, it depends on the type of problem. If it's a complex network that is generalizable, even in a powerful machine, maybe to give you an example with numbers, if you want to do image detection with a deep neural network that is general, and you want to do it at the rate of what is recommended for video processing, which is 30 frames per second, you would actually need a GPU cluster that costs $10,000. So if you have that amount of resources on the edge for each camera, for example, then that's great. But most typically, the case is not. So, and that's why we need to think of these different ways of, well, maybe I have that $10,000 GPU cluster on the cloud, but I only want to utilize it when necessary. I don't want to pay for it for everything, and certainly I don't want to wait for it for every detection. All right. Okay, so kind of like skipping through some of the slides. I think I've passed an hour. I want to keep some time for questions before we adjourn, but just kind of like to have a couple of final slides. What Croesus achieves is that kind of like in terms of accuracy and latency, these are the two metrics that we care about, and we compare Croesus. So in this column, for example, and this column here, with an edge-only solution, which is going to be only edge, small model, inaccurate but fast, and we compare it with the cloud, which is a big model, accurate but is going to be slow. And what we want to achieve, and what we show in these evaluations, is that Croesus allows us to manage this trade-off between the edge and the cloud. We get to our initial goal that we want something that is both fast and accurate. And as we can see, in terms of accuracy, we get accuracy that is much better than the edge, getting closer to the cloud. And in terms of latency, we get latency that is very close to the edge and much better than the cloud. So kind of like reaching that sweet middle point between the edge and the cloud is what we wanted to achieve, and what we could have, what we show here. Yes.
I'm just wondering for the latency or combination. What is the two numbers?
Sure. So the number here, this is for the first phase. So kind of like the two stages of computation. We're showing the two stages here and the first stage here. Yeah. Yeah. Thanks for asking. Yes. So that's a very good point. So sometimes the edge by itself is going to be more accurate, and this is the magic of machine learning. Sometimes unexpected things happen, even though that, of course, we are training on a training data set, and then we're testing on another. What happened in video 3 is that the threshold setting that we did made us not send frames to the cloud to be corrected. That actually led to wrong detections. And the edge one, because it's just relying on the edge by itself, actually achieved this. Yeah. So there's a lot of weird things that we've observed similar to this. Actually, kind of like one of the very, I think the quotes that I like the most from reading papers is a quote from an old deep neural network paper, I think 10 years ago, that said that what they showed is that they did distributed training to make it very fast. And to make the training of the model very fast, what they had to do is that they distributed on different machines, and they did not synchronize between these machines. So they're losing consistency in the process of training this model. And one might expect that because there is no synchronization, that the accuracy would be lower. But to their surprise, it actually improved. And the way that they reasoned about this in the paper, they said that the increased stochasticity of the process by distribution allowed for this improved accuracy, which is a very fine way to kind of like say we don't know what happened. Yes. Yeah. 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 Oh, absolutely, and kind of like the depending on the workload, it's different. So for example, these are 4 different workloads for videos, and each one of them show a different trade-off in terms of if you fix the accuracy to, let's say, kind of like 0.8, what is the latency that you're getting? So to your point, as we move that kind of like point, as we move that needle, as it's going to impact things differently. So if I move it to one extreme, it's going to be exactly as the edge. If I move it to the other extreme, it's going to be exactly as the cloud. And really kind of like what we allow is discovering all the space in between. Yeah, but that's a good point, because it's the trade-off is what's important. It's not one correct setting. So kind of like to conclude this, kind of like what we are trying to show is that, well, sometimes you don't want to rely completely on the edge. You don't want to rely completely on the cloud. And I think if Croesus knew about our work, he might actually be able to save his army and save his kingdom by just waiting for the gods to say that we actually mean your empire if you go. So this is about Croesus. I think we got very insightful, very good questions. Unfortunately, I think this took some time from the second part. So what I'll do is I'm going to jump to the conclusion slides, and I think we can get some more questions from there. So let's see how I can do this. Maybe just clicking really fast might be the safest way. All right, so kind of like looking ahead, what we are kind of like interested in is managing these challenges when we deal with edge-to-edge coordination, when we deal with how do we coordinate between the edge and the cloud. Of course, I'm happy to talk about all these different things and different works that we've done in terms of dealing with hierarchical organization for coordination, dealing with untrusted edge nodes, which unfortunately I didn't have a chance to cover today, but of course would love to talk about it more later. But also something that we started very recently is something we're doing in collaboration with Roblox, which rethinks the issue of failures. For a lot of you working in resilience, and where resilience is an issue in your work, we always think of failure as a machine fails, and you need to make sure that either with high availability that you don't see the failure until it recovers, or that you try to recover it really fast. However, as we encountered, and as Roblox reports also in some of their public blogs, there is a failure that happened in Roblox that made Roblox, that led to an outage of almost 3 days. And investigating different types of failures, it turns out that sometimes, even if you recover from a failure, sometimes the impact of that failure stays with you in the system. Right, and this is what we call a metastable failure, which is something that we're starting with, that actually have a huge impact also in this edge or global scale edge environment, where we're trying to increase resources so that we can add resilience and add more efficiency and real-time nature to processing. But sometimes doing this might actually lead to an adverse effect because a failure might have a bigger impact. So that's one of the things that also I'd love to talk to you about if you're interested. And to conclude, what we are trying to do is that we're foreseeing that there's going to be a huge change in how computing works right now. We're moving to this new infrastructure of the global scale edge, and in collaboration between our lab and AnyLog, we're trying to build the data infrastructure that is going to support it. And I'd like to, of course, thank all the students and all the collaborators that are working with us towards these issues. We have a bunch of undergrads, grad students, and also collaborators from universities around the world, and also some industry collaborators that are giving us more insights about what is happening, what they're foreseeing to be some imminent challenges that we're going to face. And of course, we're always looking for more collaborators. If you have any ideas, any insights, we'd love to talk more. We'd love to hear what you think about what we're doing. And of course, if you have interesting problems that we can contribute to, we'd always be happy to help out. And with this, thank you so much for being a wonderful audience. And of course, I'm happy to receive any more questions or comments or venting about different issues. Yeah, definitely. Go ahead. Thank you.
Right.
Go. Thank you.
Thank you.
Thank you for saying that.
So traditionally, our first question goes to how many IEEE members are in the audience? If you're an IEEE member, can you raise your hand?
You identify yourselves without question to an ACM meeting. I feel like I would be scared if I were you.
All right, thank you.
I'm interested in, you talked about the distributed coordination. What sort of data communication protocols are you going to be using between these edge devices? Are you using traditional internet protocols, or it seems that would be inadequate for this kind of amorphous sort of collection of edge devices that's going to be moving around as the people with their wearables or the cars move around among them? How are they going to communicate with each other?
Oh, absolutely. So, of course, I think your insight is, I completely agree with your insight. That the existing ways of communicating data and data propagation are not going to be suitable for this type of environment. What we're doing, and also your question can also be, we can think about your question in different layers, right? So there is the coordination layers that deal with data consistency and data coordination. There is the layers that deal with propagation of data, so things like RabbitMQ and all these publish, subscribe type systems. At least from what we are doing, we are dealing with the issue of how do I replicate data, how do I partition data in a way that is going to guarantee consistency of that data. So what we're building on is a family of protocols called Paxos. So Paxos is typically used in data centers to manage replication of data. So for example, you have a data item, data piece on one machine. To make sure that it's resilient to failures, it will be replicated to, let's say, 2 other machines. And the Paxos consensus protocol is going to manage this type of replication. And unfortunately, because it's built for that type of environment, it's unsuitable here. And we're building, some of our work is about how do we extend it to this environment. In general, for both this type of problem that we're working on, but I think also for different types of protocols to manage the coordination of data, I think the key element to answering the problem, how do we transition from those protocols from a cloud structured environment where everyone is a neighboring machine to one where there is a global scale edge? It's 2 keywords, hierarchy and locality. These protocols need to transition to be hierarchical, that we put neighboring nodes together to form clusters, and then to have a hierarchy so that if I want to communicate with a node, that I go through this hierarchy. And the other one is locality, where each node is going to be specializing on data that is local to it. And we've shown this with the Paxos protocol, and I think it would apply to other types of protocols as well. Yeah. Awesome. Any other questions? Oh, absolutely. I'm going to send them. I think I'm going to send them to Mark. I have Mark's email, so I'm going to send them to Mark, and he can. Yeah, absolutely. And of course, if anyone wants to see the whole presentation, feel free to invite me to some other event, and I would love to present other pieces of work. Of course, would be happy to hear as well. Yes, go ahead.
No, I would like you to come.
Oh, perfect. Yes, awesome. Yeah.
I'm very interested.
Oh, thank you. I'm very interested in hearing more insights from all of you. I think you all gave me a lot to think about as well. So I think it really goes both ways. Yes, sir. Those are the most important questions. Like usually,
we're talking about this, like how many cars entered UCI today? Are we talking about license plate readers? Are we talking about something that sits in the car that is being active? What data is actually being collected in that example?
Yeah. So in that example, it's the license plates, right? So of course, kind of like this is like hypothetical / realistic example that we're actually talking with the city of Irvine about, kind of like what is the type of processing that would be needed for traffic lights, signals. But kind of like in that specific example, it's / hypothetical, so it's not really something specific. But how we envision it is that we are doing that detection on the license plates of the cars. Yeah, it turns out to be an important question. That's from after. Yeah. Yes.
The equivalent of a human subject review process for these IRB.
Yeah.
Where these applications touch real people.
Yeah.
And I can imagine a application that would be delivered using this methodology that would be done in a way that was all on the up and up and all very socially responsible, et cetera, et cetera.
Right.
Good for everyone. And it's a license plate reader of how many who's coming into UCI Medical Center. And then someone else decides, I'm going to buy this. I'm going to sell my health remedies to potentially sick people.
Yeah.
Be an abuse or a product of insurance.
Yep.
Exactly. I can think of a lot more.
True.
This goes back, I think, to your second slide where you talk about leveraging contractors. Well, the fulcrum of that lever is money.
Yeah.
And at the end of the day, if you're collecting a database that has the potential for helping sick people get treatment at UCI Medical Center or harming people, making them the subject of concentrated advertising campaigns or worse, money, at the end of the day, is likely to be the deciding factor.
That's very well put. I completely agree, and it's unfortunately one of those issues in computing that are going to be very challenging for, I think, us as a community to deal with. I can give you maybe a couple of anecdotes and maybe how I think computing is going to go forward with these types of problems. So, for example, in our case, in UCI campus, whenever we want to install any type of devices that would impact or collect any type of personal information, there is this huge process that we have to go through, which of course at the time I would hate it, but once I think about it, or if it happens to someone else, I think that of course they're justified. And luckily it seems that a lot of places have this awareness, but at the same time, every once in a while we hear about these huge scandals about data that is being collected and used for different purposes. So it certainly is a problem, and I think you touched on the right reason. Whenever there is financial aspects that gets mixed up with data, and now a lot of companies, their main business is selling data. It can get to be a very tricky situation. So that's in terms of what I'm seeing right now. But in terms of I think where we're heading, the last 20 years, looking into applications, how they're impacting users, it seemed that regulations, privacy really had very little role in a lot of this. Regulators either were not interested, or they did not understand things, or they were in a way misled by people who are benefiting financially from having no restrictions. But now, in the last 5 years, we're starting to see that this is slowly changing. And a big example of this is GDPR in Europe. Right? So now GDPR is regulated and is enforced in very big ways, which is actually putting businesses that are misusing personal data out of business. So it's a good sign to see that it actually has this huge impact. Actually, there is a very nice website, I think it's called GDPR Violations.eu or something like that, which actually tracks all the different court rulings against these companies that have GDPR violations. And sometimes those are like not like huge scandals. It's actually like a minor thing that, well, the company did not delete, for example, my data in the allotted time, so we fine you like 100,000 euros, for example, for that type of violation. So I know from the data management and databases community, from the research side, this impact has reached us, and now we're seeing a lot of researchers, a lot of work that is being put into regulation in databases and data management. So I'm optimistic, but as people close to me would say, I think I'm too optimistic, but we'll see. Yeah, maybe is if you have a follow-up, and then we can go. Yeah.
Just as a follow-up.
Yeah, sure.
You're describing a reactive approach. There was a problem suddenly it was manifest, and now we have to do regulations, so we have to have court cases.
Yeah.
And so on. Yeah.
Right.
I'm wondering, we're on the cusp of something that sounds like new and potentially quite wonderful here.
Yeah.
How much thought has gone into sort of proactive way
Yeah.
preventing this kind of misuse instead
Yeah.
of backstopping it down the road after the damage has been done?
Yeah.
Courts and legislators.
Oh, absolutely.
Essentially, what he's describing is
Yeah.
the rate at which technology advances is
Yeah.
much faster than the rate at which you can change the legal
Yeah.
framework.
Yeah. Oh, absolutely. Absolutely.
And we talk about GDPR. Hey, that's great. That's but in those countries, that is where the people own their own data.
Yeah.
That's not America. You don't own your own data, then so
Yeah, yeah.
This does whole thing. Great for GDPR.
Yeah.
That
Yeah.
helps. And then the other question that I had was the authentication security.
Yeah.
When you have all these edge little nodes talking to each other, I mean, just right with how do they either authenticate to each other or authenticate to centralized
Right.
prevention system, injecting lots
Yeah.
of bad data in there that's going to screw up your queries.
Oh, absolutely, absolutely. Yeah. So kind of like for these two parts, I think for the first part, I think you all of you are correct. And actually, I think I'm even a victim of this kind of like or like I'm not sure if victim is the right word, but like I feel the same way that I want things to advance as fast as possible, and whenever there is regulation that is going to stop me, if the university tells me you have to wait for a week before you put that sensor in, I was like saying like no, like I have to move faster, right? But at the same time, so kind of like I see that, unfortunately, sometimes the excitement of something new, development, and even in that case, it's not financial interest. Like I would imagine that with financial interest, it would even be like more tempting to like bypass regulations and kind of like try to do things in different ways. But I think that's where regulations kind of like are being in place, and hopefully I think of like this awareness that we all have is something that is I think increasing, and I think is going to change a lot of things. For the point about authentication, it depends on the application, right? And of course, kind of like AnyLog as a system and our work in general does not go to a specific type of application, but different types of authentication are possible. So, for example, if we think about, let's say, this university campus example, if the use case is, let's say, a collaboration between a university campus and telecom companies, then the authentication process can be controlled very tightly, right? And of course, kind of like this, in this way, it would prevent outsiders from bypassing that authentication. Of course, there's always going to be the problem of malicious breaches and attacks, but kind of like in a way that's orthogonal to this authentication problem. But what is interesting, and I think of like what you're alluding to, is what if we have a more open network, right, where it's not really about a specific set of stakeholders that are working together, but rather we're trying to do something that is more open, let's say citywide or even maybe global. That becomes more challenging, and a lot of what's happening now in the crypto space, in blockchain space, in the more traditional blockchain space, where we're dealing with things like ratings, like reputation type mechanisms, where everyone can participate. However, everyone is going to have an identity, and you need to build that identity for people to trust you. If you're a newcomer, maybe someone is going to give you a chance, and maybe you have to disadvantage yourself a little bit in the first interactions until you build your reputation. But kind of like this decentralized reputation mechanisms, I think, is what needs to be put in place. Maybe something that is very similar to these reputation mechanisms actually did not start with this type of work of like decentralization. Actually, it started with the gig economy. Things like Uber, Lyft, kind of like these types of applications where you can't kind of like where it's an open market and you need to find ways to kind of like discover who's trusted and who's not. Yeah.
Because you're taking all the data that is clearly identifiable, what you're going to have between data held and data used, the most ambiguous of the data sets.
Right.
It will take a long time to classify.
True. Yeah, so certainly that's a good observation. So kind of like that spot is the spot that needs validation, and is the spot that needs to be sent to the cloud for it to be corrected. Yeah. Yeah. Oh, absolutely. And of course, kind of like that's why the knob might be important. In an application, we might care about accuracy a lot, so that window would be larger. In other applications, we might kind of like be more forgiving of errors, so it would be smaller. And of course, every application is different. But certainly, what you're saying is true. I think as more data is being put in, especially if it's diverse data or data from kind of like that is continuously changing, this might not be kind of like the most ideal approach. This approach would work better when there is more uniformity in the data. Yeah.
The other thing about the AnyLog data, it looks like there's going to be economic and political implications.
Yeah.
If you look at the world map, where the data centers are specifically in the areas that are wealthy, where we have technology,
Yeah. Where energy is cheap.
where energy is cheap.
Yeah.
So reaching other areas of the world
Yeah.
is going to be an issue.
Yeah, absolutely. I love that you bring this point up because also that's a point that actually motivated some of the early discussions of this. Unfortunately, we did not really follow through on like really tackling this problem more. And actually, it touches upon. I mentioned that we were also talking to some economists at the university, which deals with this issue, which is when we are building an incentive structure. How can we build an incentive structure that is going to incentivize people from all around the world to participate? And the problem in such an incentive structure is that different parts of the world have different currency valuations, currency kind of like the value of currency is different in different places of the world. So for someone to participate from one part, it might not be as big as an incentive to participate in a different part of the world. And also in terms of resources, someone, let's say, in a wealthy country might have a lot of resources, so they really dwarf any participation from, let's say, disadvantaged countries. So how do we incentivize the participation while ensuring that even if you're, let's say, contributing less, but maybe from a disadvantaged location, you would still get rewarded in a way that is proportional to the situation that you're in. Yeah, but it's a very, very difficult issue, unfortunately. Yeah. Yes.
I was thinking it might also be a lot of this seems to be potentially very localized focus of it might be the incentive to deploy it to some place that has less resources is cheaper to deploy the compute close to there than have it sent all the way to a place where there's a centralized data center.
Yeah.
So that might be the incentivization of it, or it's not whatever's being tried to be done doesn't have a market for that area. So
that's true.
I'm not going to pay for that, and so if something develops there that we would like to see this type of thing, is this type of system could be, it's like, okay, we developed this fog compute capability that'll scale better than building a data center, taking months and months,
Oh, absolutely, absolutely.
bringing all the data into that one area to go back out.
Yeah. Oh yeah, that's a very good point. And actually, I think what you observe here is very nice, which is there are, in order if it goes both ways. Sometimes a disadvantaged place in the world might actually have advantages when we think about like resources or deployment. But also there is, like, to add to what you're saying, sometimes the opportunities are more important. So for example, if you're in a disadvantaged place, maybe data centers are first, they're farther away, meaning that kind of like this need for edge localization is more important. And another thing is that the infrastructure. There is some work in the networking literature that investigates this, and there is, like, especially when you think about rural areas in disadvantaged countries, access to the internet is difficult, right? So, and the reason is that there is no infrastructure that connects you from that last mile all the way to the internet, and these kind of like more distributed, decentralized solutions become more important because, well, if I'm in this rural area, most of my interactions, most of the applications that I care about is really with my surroundings. Why do I need to go to the data center in Seattle to send a message to my neighbor, right? So kind of like, yeah, I think it's all like opportunities, challenges, like all this play together. Very, very good questions. Very insightful. I wonder if anyone would like to ask anything more.
Yeah, do we have any? This will be the final question. Any takers?
All right. If not, I just want to kind of like say thank you again for all of you. It's been a pleasure being here. And again, I want to say that all of you were a great audience, very insightful. I have a lot of things to say to my students tomorrow about all the things that you said to me today. And of course, my contact information are available online. I'm always happy to talk more, to discuss more, have chats. This is really what keeps us going in the lab. So please be in touch.